So right here, we're going to solve this one. This one's nice. There's only one binomial. All right. In fact, remember, the main thing we got to do first is to force the denominators to match. Okay, and the nice thing is that two of the denominators already match. The bad news is that two of the denominators don't match the other one. Maybe I'm overemphasizing that, but here's what we're going to do. What I would like is to force the letters, the variables, to match first, okay? So I got an x, I got just a 4. It's missing the x, okay? So I'm going to go in there, I'm going to take that 4 and multiply it by x. Now, this term does have a denominator of x, but if I do it to the denominator, I need to make sure to do it to the numerator as well. Well, that was fun. But we're not done yet, because this denominator has a 4, this one doesn't, neither does this one. So what I need to do there is I need to take that 4 and I need to multiply it by this x and also this one. Now let's do it one at a time, okay? So the first one on the left, I multiplied the denominator by 4, so I need to multiply the numerator also by 4. And then the last one as well, I'll multiply that one by 4. Now I'm putting the multiply by 4 over here just so it doesn't look like 4 minus 1. Okay, what I've done here is I forced every single denominator to match. What that means also is that we're dealing in 4x's. So all the sizes of these are the same. And what I can do now is I can rewrite this without any denominators. So I've got 4 times x plus 3 minus the 5x rather. And this equals, I'm just going to do the negative 1 times 4, which would have been negative 4. Okay, this is the equation that I'm solving now. I'm not worried about anything else. By forcing the denominators to match, you can ignore them. And if we had started with this, I think some of you guys would have been like, hey, that's pretty cool. We can do this all day long. But by starting it like this, you just had to force it to become like this. That's it. So from here, by solving this equation, what I'm looking at is just, it's an equation with one variable, by the way. So that means we would look for any distribution. I found some, because the parentheses, that's 4 times x, which would be 4x, and then 4 times 3, which is 12. Remember, distribution is always multiplication. And then everything else, yeah, it just stayed the same there. Okay, so this is my new equation. And now after distribution, always look for any like terms to combine. And I got some x's that I can combine. It's 4x's minus 5x's, which would be negative 1x's. The 12 positive just drops. This still equals negative 4. Okay, now that I've done distribution and combining like terms, I can now use principles of equality to solve this. So my first principle of equality, I'm going to isolate that negative 1x. So I'd just like to be able to drop it, right? So this would then equal, I got to get rid of that 12 in green, so I'm going to have to subtract 12. That means I'm going to zero it out, right? So subtract 12 on both sides. That does zero it out. Negative 4 minus 12 is negative 16. And then finally, on this one, I'm going to force the coefficient of x to become a phantom one by dividing it, the negative 1 coefficient by itself. If I do it to one side, I got to do it to the other side. I'm showing the division a little different. But negative 16 divided by negative 1 is positive 16. Well, that was fun. But now I've got to check, right? So I've got to go back, and I'm going to check on the left side first, okay? I'm going to put a question mark above the equal sign because I'm checking for truthfulness. Remember, if by chance it becomes false, then I know it's not a solution. But this is the only solution I found. I would just say there is no solutions, which could happen, okay? So yeah, now I'm using the original. In fact, maybe I should rewrite it. So the original was x plus 3 over x minus 5/4. And then we're checking for equalness, negative 1 over x. But now, we're pretty sure, at least I'm not seeing any errors, but I'm going to take all my x's and replace those with positive 16. Now on the right, I got negative 1/16. And that's okay, because we just had to replace that x. But on the left, I got to put this in my calculator. So I got my n over d, 16 plus 3 over 16. By the way, I'm hoping very badly that this is true, because if I made a mistake, we're going to have to go back and find out. But minus 5/4 rather, I got on the left side, again, I was checking for truthfulness, I got negative 1/16. As far as I know, that matches, right? That's true. So now I know that I have in fact found the solution. So we didn't make any errors apparently. This is the solution, boom. In future problems, of course, is this just gonna be an x? No, maybe it'll be like x minus 2 or x plus 1. And then we gotta force this x plus 1 to match maybe here or both, who knows. Now, you need to make sure that you're using this one in case you made any errors from here to here even. You could technically check in this one or this one or this one. But again, like if you say, well, let's see if x is negative, or let's see if x is 16. All right, that's not very much to check, but again, you're skipping some work. That's the whole idea of checking, not just to make sure that it's true, but just to make sure that you did perform your operations correct. Now, coming back to this problem is, when we look at these original fractions, you can tell, at least in this one, right away, like from the beginning, you could have told, hey, again, we're looking at the domain, what value of x wouldn't work here? 0. If you made x 0, this fraction doesn't work, neither does this one, okay? Now that's something you could have noticed from the beginning. So if we had gotten x equals 0 down here, then when we put it in, we would have gotten an undefined value from this fraction. We didn't. Of course, I'm just kind of leading into other things, but expect that possibly to happen. That's what I'm talking about by checking. Like you could have gotten x equals 0 and then checked it and said, well, that's impossible. You get an error in the calculator, which we don't want.